Hello guys, good afternoon. Would like to talk to you today about missing values detection and cleaning. So if I want to talk about cleaning, it's going to involve so many topics. One of the topics is dealing with missing values. Dealing with missing values involves detecting missing values, where they exist, locating them, and then what to do next. Okay, I know that there's 20% of this column includes missing data. What to do with it? Or a couple of columns together. Different decisions that you need to make depending on your understanding of the context, depending on your experience, and depending on the analysis that you or your senior data analyst would like to perform. So for now, we're going to talk in this class about missing values with Python, detecting them and cleaning them. In a later video or class, I will be talking about what we call them, I call them kind of extreme values. So with Python also there's what we call it an extreme values. So these are also very interesting to deal with. They are not missing values, they're extreme values and or irrelevant values. Correcting irrelevant values, especially in categorical variables. And then we also have the topic of outliers. So how to deal with outliers. Let's get started. This time I already practiced before shooting or recording this video. And the first thing we're going to do, as usual, we're going to copy importing all these libraries, which is the first one is Panda. We importing it as PD, NumPy as NP, and Matplot library. We're gonna get it as well as Seaborn library as SNS, and then also other libraries for regression. This is for later. In fact, I used to keep a very long. But this sklearn also we could use it. In fact, we could use sklearn also for dummies. We used it last time for dummies. But for this kind of class, I used to teach this as one whole project. But then now with the flip and hybrid education, I learned to split into smaller projects. So I'm going to just decide to, this is a new. Let's start a new project, a new file together. So I'm going to redo the missing data here. So I'm going to have a new Python file, and I'm going to import the necessary libraries, pandas, NumPy, and the matplot library. So this is the first step, of course. Then we're going to read our sample data. The data that we're using is C example2 missing data.csv. Of course, I'm going to provide you with this data set on Moodle, so it will be available on Moodle. As I usually say, I don't know what happened to me that I did not add the underscore here. Usually, I don't like to have spaces in the data files names because I usually use also R as well for my analysis, like for research. So whatever my intention is research, then I would definitely not have any spaces. And this probably could and should be the standard way of doing things. Why? Because you might need to use different platforms, and some platforms are very sensitive to having the data sets here. Where are they? Where are the data sets? I haven't uploaded them here. They should be uploaded. Here they are, CSV. So I'm going to be using C example2 missing data CSV. Of course, I talked to you about how to upload it. So wherever you saved it, get it from here, open it, and then you will hit the key upload again. And then you can read it easily as you have seen here. So I'm going to read it. I'm reading it using the pandas read underscore and the data type, and I'm gonna call it df, referring to data frame. So I'm gonna store it. I'm gonna store the output of this in a data frame, df. Okay, and here is the output. As you can see, I don't have that much data in this Excel sheet. Why? because this is just for training. I'm starting with you slow, but then starting next week, in fact, we are going to use the county dataset. It's a dataset for predicting houses prices or housing prices in the United States. There are many other datasets for predicting real estate prices, and this is quite an interesting exercise for us to tackle in this semester. So for now, let's just focus on the functions. What kind of functions we are going to need to clean any dataset. And with this, even though this is a very small data frame, you will be surprised on the amount of things that you need to do. First of all, as you can see here, you can observe that we have a whole line, a whole row record of data, a whole record that has NA, that is by mistake. This record is probably added at the very end or in between the rows. This is like, even with your eyes closed, the first thing that you need to start doing is with data cleaning and with missing values is to get rid of such lines. Sometimes it's rarely, to say the truth, it's rarely that you will have something like this in any data set, a whole a row with all not a number. This NaN indicates not a number. And NaN is an indication of a missing value. There's Na also. In some other files, you might have a dash for accounting, kind of like dash cell, especially with Excel, and so on. So in any case, these are indication. This is an indication that this is a missing value here, NaN, not a number. All right. So what do we do? So the first step, we need to have the data types. If you want to take a look at the data types and the shape. So we have 5 rows and 6 columns, as you can see here. So the first thing I like to do always is, this is what we covered previously, that you can get the data frame, whatever name that you gave it. We gave it df as a name. You can append to it the dtypes method from, or class from pandas, and get the data type and the shape. Another thing that I would like to introduce to you this time is how to get the list of columns that are numeric. I like this exercise because, or I like this piece of code, because this is very important for you to, especially in processing very big data sets. So you want to know how many, the way that we clean and prep numerical values is different from that of categorical values. Yeah, categorical values require dummies, right? We have to convert them into dummies. We also need to detect the NA in them and make very difficult decisions. Are we going to drop it? Are we going to drop it if it is an NA with another NA from another variable, or? So first step here, we need to just get to know or select or detect the numeric columns. So this is df, the data frame in numeric, and it is df dot. So we're using this class select dtypes. We already talked about dtypes, right, earlier over here, df dtypes. Now we are using it, select underscore dtypes include equals np number. So a numpy is number here, is the, so and here's the numeric columns, put them in this df in numeric, the output here of all the numerics, df numeric, put it in columns and values, and print this in numeric columns. So you're just putting it in numeric values, because if you, over here, if you just want to see the df in numeric, it's all right, you can see it. So you either stop here, you either stop at this line and say, I just want to see the df numeric. So it's age, it's a pre-test score, it's post-test score. So that's fine. I usually do that also. So you just look at the data here with age, pre-test score, and post-test score. So that's fine. But if you want to put it in a list for later processing, if you want, then do so. All right. The second thing to do is now to also identify the non-numeric. All right. So I'm going to identify the non-numeric similar way with the NumPy library. I'm going to get .number, but this time I am not going to include it. I'm going to exclude it. Exclude all these guys that are numeric and give me the df non-numeric. I just stored it in the df non-numeric, and now I get the first name, last name, and sex or gender. And also you can put it in a list format over here, as you can see, and print it in columns and values. All right, just the columns values here. You're just identifying first name, last name, and sex. So these, you just want the columns names or labels. You don't want the whole data frame. Up to you. It's all completely up to you. I just wanted to let you know that you could just stop over here and you're just fine. All right, so now that we know we have three variables that are numeric and the other three that are categorical, we're going to start probably more organized way, in a more organized manner. We're going to start setting up a protocol. Before anything else, setting up a protocol. What are the things that you're looking at when attempting to clean and to prep numeric variables compared or versus categorical ones. All right, let's get started. So what's next I prepped for us? If you attempt to create dummies before cleaning the data, what's going to happen is, as you can see here, if you attempt to create dummies, for example, for categorical data like sex, as we've seen earlier in the data frame, yeah, we have yes, no, and NA. You see that over here. Let's do it one more time. So over here, taking a look, you have NA. For example, if you create dummies, let's do it. Even though it's just consuming our time, but let's do it together and see what happens. So you're creating dummies here, female and male. So what happens is, take a look. You have male is 1, then NA. So over here you have 0, 0. It's either you leave it this way because your sex is maybe male, female, or undefined. So it's another third category. So you could do that also. You could just say maybe NA in the data collection. NA, in fact, you need to go back to the step before, the data collection step. All right, you need to ask the people that you acquired the data from, is this NA, what, in context, put it in context. Did you ask people if they are male or female and that's it? Or did you ask male, female, other? Or I do not wish to specify. And then when you got the data, I do not wish to specify, or maybe the person, if you are neither, actually if you do not wish to specify, it will be a third category. But let's say that it's male, female, and there's a note in there. If you do not wish to specify, leave it blank. So there is a big chance now that you have mixed up, either people had do not wish to specify or just forgot to do it. So you need to, when cleaning the data, you need to really understand the instrument, the data collection instrument, or if there's no instrument, if it's a POS kind of data, point of sale, then like on the cashier kind of data, automatic kind of data collection, then you know you might also interpret this differently. Let's say that this is not very in this situation here, depending on what NA means. If NA means a third category, then you have to create these dummies, and that's it. Keep both dummies, you know, because there's a third dummy which is here, 0, 0, 1. We don't, and we talked about the number of dummies appended to the original data set being n-1, so you're fine. But if NA means it's a missing data, then it's a different story. Then because of this, I suggest that you do not start with creating dummies. So I suggest that you do not start with creating dummies. First, prep your data, meaning prep your data, make it neat, meaning clean it. All right. All right, good. I hope that now you understand it better. And if you're thinking that, so why did you teach us dummies before? Yeah, of course I'm going to teach you dummies before so that you can understand what I just explained right now. All right, I just noticed that we have it untitled, so we probably need to have it to give it a name here, which is missing data detection and correction. This is for video. This is for me. this one for me. Because I have it now already done, and then I have it for the video, and in class I'm going to do it again with you guys, so it's all right. All right, so now we understood this very important discussion, I believe. Now let's go ahead and take a look at the description of the data. It's very important that you, first of all, take a look at what columns are numeric, what columns are categorical, and then make sure that if this is 3 and this is a 3, and previously when you had, of course, here escape, and if you hold down the escape key and press B, you would be able to create an extra line here. And if you have def.shape, for example, and you understood you have 6 columns and you have here 3 and 3, this means that good. You're fine. You had them all exclusively belonging to either numeric or either categorical. Okay, there's no kind of variable like object is not categorized here or there. Yeah. Now let's describe the data set. Now descriptive analysis comes at the very top of the tree if you're doing any data preparation. So this is what we call it, descriptive analysis. Descriptive analysis, as you took in statistics, include the mean, the standard deviation, the minimum, the maximum, the frequencies if there is any for these guys, the categorical, of course. And then also we're talking about, most importantly here, the first quartile, the mid, and the third quartile, first, second, and third quartile, 25% of the data, 50% of the data, and this is very important statistics. Maybe over here, because this data set is so small, we have most of the data here is NA. Unfortunately here NA is because these are categorical, but this is the mean of the age, for example, is 43.7. There's no mean for this categorical variable. We have 4 here, and then we have a pre-test score 3, and over here a post-test score, the mean of it is 52 of 3 different. That's really interesting. The pre-test score is 3, but the mean of the post-test score is 52. All right, in any case, these are kind of like important descriptive statistics. Don't worry, this doesn't sound very exciting or interesting or insightful, but once next week, when we take a bigger data set of thousands of different records, like the real estate data set, then we will find interesting insights we can arrive at by examining the descriptive statistics. So descriptive statistics. So I just want you for now to kindly get used to using the describe here function or method, DF or dataset or whatever name that you've given to your data frame that you've read. Describe and include all descriptive statistics. If you just write here describe, sorry, without the things, you will have here first of all you will have here the describe for only the numerical variables. That makes sense. And then look at the difference here with all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then all the variables. Without it, look at the difference. You will have 1, 2, 3, 4, 5, 6, 7, 8. So there are also some missing statistics here. So if you're thinking, so why do we need to put all? Anyway, these statistics are more relevant to numerical variables because we are missing some other statistics here. Did you see the difference? This one has the frequency, I think, for the categorical and the top for categorical. So I mean, it is not bad to just include all. This is what I do, and this is what I recommend for you guys. All right, so first of all, we described, this is our protocol. So our protocol, let's start it, you know what? I'm gonna start the protocol, typing it with you here. Let's create it together. So first of all, what did we do? Let's take a look. So first of all, we have started with identifying numerical versus categorical variables. Now that we have a numerical versus categorical, yeah, the second step that we've done is descriptive statistics with the describe. So descriptive statistics, all right, with the like df.describe, all right. Then what happens next? Then now we're gonna start our investigation. So all right, so now let's take a look here. Here I'm just trying to detect the missing values. So in general, we're trying to get the percentage of missing values. Of course, you can, it's a better, this is the if you go onto the internet, you probably find most tutorials talking about df.isNA or is missing, not available. And then some are more advanced that they append the .sum. See what happens. For example, here, I'm gonna hit down the escape key and hold it and use the B here. So what happens if I just do this? So I'm getting here, wherever there is a missing value, it's a true. So there is a flag, true, 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 true. These are missing values. Okay, if the data is too huge, what does this helps me with? This is because the data frame is really small. I can see it, I can visualize it. But when the data set is really huge, with 30 or 20 variables and thousands of records, how is this going to help me? It's not going to help me much. But maybe if I compute the sum, then I would be able to get the sum of missing values for each variable. So here's the list of variables, guys, that we have. As you can see, 1, 2, 3, 1, 2, 3. And this is the number of the sum of missing values. Now, what if I even want a better measure? I want to find the percentage. If I do that, which is if I divide over the total length, you see this? So you have the sum of missing values over the length of the data frame. So what am I getting here is I'm getting 20%, 20%, 40%. If you want to be really neat, you can just put it in between the brackets as above and multiply it by 100, so it's like 20%. But it's the same if you just put it over the length. This len means the length of the data frame. So this is the length of the data frame, meaning how many records we have. So in general, we have, how many records did we have here? We have 6. So we have like, do we have 5 or 6? We had 5. We had 5 records. So over here, let's see if we can do this. Okay, so we have 1 here for first name, 1 missing value. For last name, we have 1 missing value. 1/5 is 20%. That's true. And 2/5 is a little bit 40%. That's true. So if you, yeah, you can do that, but I just wanted to make sure that it is computing it correctly, which is true. Here we had 1, so 1/5 is 20%. So this is how you compute the percentage, and this is important. Now, this is a small data set. You can verify your function or your calculations by easily. You say 1/5, but in bigger data sets like what we are going to work with next week, then you probably need a formula like this to guide you through. Okay, the next thing, okay, did I put this on the other file, the file that we're working with? No, so let's put it here. So now we knew that we have 20%, 20%, and 40%. Now, in bigger data sets, it is maybe very not maybe, but it is super beneficial for you to visualize missing data. And I'm sure you probably, some of you, I hope I am adding to your knowledge. I am not sure if the professor in the Python and visualization class has given you the heat map, but I know that I've given you the heat map in Tableau. This is the same situation, but this heat map, instead of having an intensity, it just have 2 colors, one in blue indicating a certain value, and one in yellow. Let's take a look. Columns in the data frame, these columns all the way to 19. Actually, we don't have 19, but this is because I was working on the same code for the real estate data. We really don't have 19, but it's gonna print up to 19. If you remember, guys, this is the list columns, and this is the list of the columns. And if you use the column here, yeah, for example, you use from 0 to 19, it's going to give me the same results. You see, it's first name, last name. But if I start from 1, do you guys remember when I told you the index, the index starts from 0 with lists? If I start from 1, this gives me a range from 1 to 19. Look what's going to happen. We're going to start from last name. We skipped 0. So if you don't want to skip the 0, you can just add 0:19 or 0:6, in fact, or 5 in this case, which is pre-test score and post-test score. Yeah, it's not post-test score. Okay, from 0 to 6. So this is 0, this is 1, 2, 3, 4, 5, and whatever it is here. So 0 to 6, then you can print all the, include all the columns that we have. Now, first 30 columns. Now, first 6 columns will be something like, because we have 6 variables, but even though it starts from 0, you can just start by omitting the 0. So start from wherever the index is to 6, until 6, stop until 6, stop until 30, as it is populated, whatever populated until 30, whatever populated until 6. So this is how we refer or point to, what do we call it, recall the values of different columns. Okay, so what if we wanna, for example, start from 0 until the end? So I don't know what the end is, so it's the same here. You see, I started from 0 until the end. What if I want to start from 3 or 2 until the end? You can just 2 until the end, age, sex, and all that. So you can also do it in this way. You say 0 until the end. It's a better way, actually. So you can start from 0 until the end of the number of columns that are populated. All right. So it's okay. Here we can have it like 6 because this one works best with us. So this is the first 6 columns here. And here you can see that we have the colors. We have 2 different colors, as you can see. We have yellow and blue. So specify the colors. Yellow is missing and the blue is not missing. So this is a heat map showing that here this is not missing and this is here is missing. All right, so as you can see over here we have 1 missing value, and over here we have 2 missing values for these 2 variables. So these 2 variables, the pre-test and the post-test, has 2 missing values. It has the most missing values, and here we have 1 missing value. Okay, and these are the records. So basically with these we have 1 record here, whole record has a missing values. So we need to get rid of this 1 whole record that has so many missing values, so we will end up with all blue over here. So in any case, let's take a look. This will be very helpful, guys, next week when we have bigger data set. Right now I just want to explain to you what the code is and explain to you the protocol. So the protocol is descriptive statistics. Then next is detecting missing values with percentages and visually. Yeah. I'm sorry. So far, this is the protocol that we are following. These are the steps that we are following, and this might help you a lot when we are doing the assignments or quizzes. All right, and in fact, maybe it will be a good practice to have a box over here that has the corresponding method or code that you could use to execute a certain a step. All right. Now, I would like to show you something interesting. This is a piece of code that it includes a function. We probably haven't covered functions yet because functions is supposed to be, let me check my calendar. I kind of delayed functions for you to study on your own on Wednesday, right? Python conditional. No, we actually talked about functions. Oh no. Oh no, we haven't talked about functions. So functions is on Wednesday. So functions and loops. Python conditional statements and loops and Python functions also on tomorrow. So let me explain a little bit about functions. However, please don't worry about this. This gives you the same exact result here. I probably need to skip this. So I'm going to skip this for now. You know why? Because we're going to use it again in the bigger data set. So I'm going to skip it because I don't want you to feel as if you are lost. This, you will better understand it tomorrow. Next week actually, when you take the makeup class on Wednesday tomorrow, so you understand a little bit of functions, and then we're gonna come back and I will describe this in more details. It's not rocket science. This is here a built-in function in the library that helps us create a function. My function, I called it missing underscore values underscore table. Functions with Python always starts with a lower letter and also have and doesn't start with numbers, and we don't have any spaces, so we fill the spaces for readability with underscores. So this is a missing values table, a function that will compute the missing values in a table, and you need to give it an argument. So you input an argument into this function. This argument here is the data frame. In the example of the video example on Wednesday, the argument that we've given is actually x, which is a variable, like x is equal to 2, and it's like a system of linear equations that you need to compute or to solve. So we have missing values, df dot is null dot sum. So you are summing all the missing values and storing it in missing value. Missing value percentage, we've done that just now. We knew how to, in fact, break this into, I showed you how we computed this. So we definitely put the is null here over the length. You could actually use miss value here and put it instead. So you could put miss value over the length of the data frame. Miss value table is nothing but the pandas here concatenate this miss value here with the miss value percentage, and of course we always have an axis, and then this miss value table underscore ren underscore columns is just miss value table rename. You're going to rename it into the following columns. The 0 column will be missing values. The 1 column will be the percentage of total values. This is why in the output I have missing values here, percentage of values, and then that's it. You have also here a statement that you printed. So you printed a statement your selected data frame has, and then of course when you are appending or concatenating a string here, your selected data frame has, which is a string, and then you want to add a number, which is the output of the df.shape. How many values, how many columns you have, which is the df.shape, gives me how many columns. So I want only the output in df.shape gives me 2 outputs, right? In parentheses. If you put, now try df.shape, it will give you 5 and 6 in parentheses. So what I need is I need the columns, which is the 6. So let me show you. Let me show you. So here df.shape returns 5 and 6. 5 is here, 5 is here, is with index 0, 5. So 5 is the first output. How about the second output is the 6, which is the number of columns. So this is why I had the number of columns here. I had df.shape 1, meaning return to me not 0, the output with index 0. I want the output with index 1. So I'm returning here the output with index 1. But because this output is a number, so I might get a problem. So I want to put it as a string. So I'm converting here with the string function. It's easy to convert this numeric into string. So I'm going to just return it or convert it to string. So this is why I'm putting it into string. So always whenever you are having a string here and you would like to concatenate a number to it, just add a string here and put it in parentheses, which is a string function, and taking this argument to convert it into a number. Then here you have whatever columns you have. Of course you have the backslash here. The backslash, or called an escape character in Python. This escape character means when I put it before an n, it means a new line. When I put it before when I put it before quotes, it means these quotes are not quotes for coding. These quotes are quotes for writing, for example. So this escape n has a meaning. Escape n means a new column. This is why you start a new line. This is why in your output here, when you executed this piece of code that I've written, I have here your selected data frame has 6 columns, and then a new line, there are 6 columns that have missing values. Then I have there are how many columns now has missing values. Same logic. So I converted it into string, and then missing value table rename it. You added in there and the shape of 0 here, how many missing values, or how many columns, sum of columns that has missing values here. And then that's it. You return the missing values tables, and this is how you return the whole data frame. You call the function again. So you call the missing values table function, and don't forget to include the data frame here, and then this is the output. You're getting the output. Okay guys, so this is the explanation very quickly, but if you want to digest the functions in a more easier way, you probably need to wait until you watch or you tackle the Wednesday class with me tomorrow on Wednesday. Okay, so we're going to take this and this together, and now over here we have data frame 6 columns, and these are the number of it's kind of like starting with the variables with the most missing values. So today an extra thing that I taught is just converting a number into a string, especially when you are concatenating inside the print function. Also the escape character here with the n, it means a new line. You can also have an escape character with whatever, like over here you have an escape character. If you want to add like an apostrophe, like it is, but it's you want to write it and you have an apostrophe. So you can add a backslash here and apostrophe after it, then it will print the apostrophe. Okay, good. Otherwise it will consider the apostrophe is the end of the text, especially if you're not using double quotes. It will give you a total mess. Okay, all right, so having this done, so we were able now to get a very nice, this is especially important, and this is equal to this, isn't it? So here's the list of all variables and here's the percentages. This is gives you the numbers and the percentages. If you remembered guys, I put here print, and I put print this alone and print this alone. I got a little messy because it aligned the first values, which is the numbers, and then next to it, look what happened. Listen, I want to show you why I did what I did and put this nice code together. Because when we put this here, and then we put the link and then we put the whole thing together, look what happened. I had the first output, which is the numbers of missing values, and then look at that, first name is here and here's the percentages. I want a table, a nice table like this. Here's missing values and here is the percentages. So for this purpose, writing it this way won't give me really a nice output. So if I really need a nice output like this to show and to copy and paste in my presentation, then this is the code that you need to use. You see? So this is the kind of things that I'm sure you learned with the professor in coding with Python, or with the professor also with visualization. Probably with the visualization class, you also learned how to create this tabulation, very nice tabulation of your results. Probably you focused only on bars and pie graphs. That's also valid. If you haven't, I'm glad you didn't, because then I added value. If you had learned this, then maybe my explanation hopefully has helped you better understand it. If you haven't learned it, I'm even more happy and happier, because then I added to your value. I added value to your understanding. All right, so there's a lot to learn with Python. So I'm sure you've learned other more interesting things with the other classes. Hopefully I'm trying to add value here. All right, let's see. Are we up to date here? Detecting missing values, percentages, and visually with the heat map. Of course, we've done it now. Where is it, the heat map? Oh, we forgot about the heat map. Okay, so let's get the heat map. I just didn't add it to my latest here. So now we have a nice tabular format, and now we have the heat map that I already explained to you, and we already took it in Tableau. So in Tableau you understood what a heat map is really, and now you're just using it with Python. All right, now let's talk about next I want to talk about data cleaning. What is it that you could, what course of action that you could do with the data cleaning? The first, you need to drop all the rows that has all NA. So let's take a look at the data frame again. Look at our data frame. Row number 1 here has all NA. These are unnecessary rows. So first thing, you need to learn how to drop all records or all lines or rows that contain all not numeric or NaN missing values. How do we do that? We do that by, let me just call it here df. Let me get rid of it once and for all. So this df, I told you that I like to always rename the data set again and again, but just for now, for simplicity, let's say that we want to override on the df data frame and drop NA, drop missing values, where, when all, how, when all of the lines here, as you can see, are NA. So now we have 0, 2, 3, 4. So we got rid of the first, the number 1 here. Okay, so now this is one of the things that you need to do. The first thing you need to do is to drop records. So this is here, drop records with all missing values. So this is the thing that we need to do. This is one of the things that we need to do first, regardless of either you're numeric or either you are categorical variable. Now let's investigate more into cleaning also the data set. If you want to clean the data set in general, you want to clean the data set and drop all missing values. Let's say that you were given the green light to drop all records that have at least one missing value. You don't want it. You don't want the whole record. You have a lot of big data, and the analyst is very busy. You as an analyst very busy, and you want to do a preliminary analysis. You don't care if 1 million records, you end up with 500,000, or let's say 10,000 records, you end up with 5,000. You're just fine with this preliminary analysis very quickly to crunch the data. Then you can clean the data by clean the missing data by immediately cleaning the dropping. So here in this code I have df cleaned, which is df in our case, df dot drop na. You're gonna drop all the na. This includes dropping this whole row and dropping this whole row because it has 2 NAs, and you're gonna end up with this data set. As you can see, Jason, Jake, Amy, they all have their data populated. So from 5 records, you will end up with 3 records only with all populated data, no missing data. So you could do that if you have a lot of data and you don't care about the size, and you're fine with, you're also tight with the time, most importantly. Now, in some cases, especially as a student working with a data set, this is not what you want to do. Do not drop all the missing data. You want to really preserve as many data points as possible, because with the bigger data set, with bigger sample size, you can use more techniques, but higher chances or more chances of using a variety of analytical techniques. Maybe with every single survey that you collected, it costed you money, or it costed you a lot of time and effort of persuasion to complete the data, and maybe also some of the columns might not be as important as others. So let's see how we can just avoid this easy solution, because this easy solution comes with a price. Dropping all NA comes with a way much smaller data set, let's say. So in this case, let's talk about a way of considering. First of all, you could drop records with a minimum threshold value, threshold of missing values. What does that mean? This means, for example, a record that has 50% of its values missing, a record here that has more than 50% of its values missing, I don't want it. A record that has maybe a certain percentage, for example, 5 or what, let's take a look here what I did. I said here drop rows that contain less than 5 observations. So I can accept a record that has 1 missing value. If you have more than 1 missing value in these 6 records, in these 6 variables, of a total of 6 variables, you have 1 missing variable, I can tolerate that. But if you have a record with 2 missing values, like 2 variables are missing in that record, then I do not wish to keep that record. So in big data, for example, a very huge data, if you have 30 variables, you probably want to have the same percentage, 1/6. So, or 15% or 10%. If 10% or 15% of the, you need to talk about it. You need to really talk about it. So you could also attempt to do that. So this is one option. So this is option, I'm not going to call this option 1, in fact. This is not an option. Getting rid of the whole row, this is a must. You need to get rid of all rows that are irrelevant, that are nothing, like useless. Now this is an option, but I'm not going to put it as an option. This is the easy go, like this is the easy solution that comes with a big price tag, yeah, which is basically a way much smaller data set. All right, so we have option 1, dropping rows with a threshold of missing values. So what do we do here? We just take the drop NA and add the argument a thresh. A threshold means like a cutoff point. A threshold 5 means I want 5 or more values. So these are here, as you can see, we were able to clean the data set same way as getting rid of all the NAs. But in bigger data sets, of course, I'm giving you this data set just for a sample, yeah. But in the future, when you're working with a real data set, you really need these kind of functions with the threshold. So I'm going to put this here because it could help you and memorize and understand what is it that we're doing. Okay, next. Now that you detected here, here that you detected the missing values, and you examined with the data collectors what the context is, and better understanding of the data collection instrument, and you talk to your analyst also on what kind of techniques they want to use or they want to consider, or maybe you know the objective, so you should know what kind of techniques you could be using, and you have and the time limitation and all that. Let's say if you are in a hurry, then you probably need to use the drop NA function altogether. If you're not in a hurry, you could probably say that I want to keep a certain rows with certain NAs, and then I'm gonna solve or correct the NAs. How do we correct these NAs? Let's take a look at data correction. Let's take a look at the data correction. How do we correct this data? First thing that we do with the data correction is populating the data, considering to populate the data, either dropping it. So we talked about detecting and dropping lines here. So this is detecting and dropping lines. Over here, we're going to talk about the data correction. And data correction, other than dropping the data, means populating the data, the cells with smooth values. Okay, let's see. So this is the DF. Let's take a look at our DF right now. Okay, so our DF, as you can see, has a missing value here and a missing value there. So we could populate this missing value with an average. So the average of 3 and 2 and 4 is basically 3 plus 2 plus 4, which is 9. 9 over 3 is 3. So you want the computer to do this kind of operation for you. You want Python to do it for you. So you want to fill in the missing values or the missing cells with an average of the other values in the same column or in the variable. So let's do this together. So you want to fill in the missing values with the average of the average or the mean, right? The mean is the same as the average or the mean of the variable, right? Of the variable, and that is the same as the column. So this is how we do it. We say that I want to get the pretest score variable. How do you get the pretest score variable? Let's take a look. Control B here to create. If you say a pretest score, the computer will tell you that it is not defined. Why? Because as I told you earlier in previous videos, you really need to attach or append the mother's name here, which is the data set, the origin, the root. Where is it coming from? It's coming from DF. So it's now been able to read it for not a number 2 and 3. All right, so I am talking about DF pretest. I want to fill NA. So there is a built-in function, in fact, in our library called fill NA. So fill here the missing values. So this is the first step here. So we are going to call the pretest score over here. All right, and then we are going to fill the missing values. And then what are we going to fill it with? We're going to fill it with the average. So I want to get the average of the DF pretest score. How do we get the average? Do you remember how we did get the sum of the NAs here by appending dot sum? Do you remember here? DF dot is not NA is missing and dot sum. Something similar, guys, you see. So over here we are getting this DF, the variable, and in fact we are getting the mean. There is also here a function called mean, so we are getting the mean of it. But for the fill NA function, you also need another argument. So you fill it in with whatever you want here. We want the mean, and you need to put in place true. So just put in place true for now, and then this will be our code. You see that it's telling me you might have certain issues, you know, slicing the data frame, but I should be fine. So here we having 3. This is what we've done earlier, right? Okay, now nice. So this is one of the ways that we will do to fill in the value. I am maybe disconnected from the internet a little. Okay, I'm sorry. So the next way, the next what did I do wrong? Let's read, but I don't have time to read right now. Oh, okay. No? Error? Ah,そっか。I have a problem, I think, with my internet connection. Okay. 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 Okay, let's keep going for now. The second post-test score, I could do it same way, or I could, in fact, I might want, for example, compute the mean, computing the mean, yeah, but based on a grouping variable. For example, in a previous video, when I was explaining also with Tableau and cleaning the data, I was talking about the sales data and how sometimes if a missing sales data it falls into a weekday, we might in fact average only the weekdays. So we might need to create a flag for weekday and create a flag for a weekday and weekend. And whenever there's a weekday in within a certain month, yeah, we have to average the sales, and this average will be given to that value. Or in that week, in that specific week, you have to have a week dummy there, and that week you would like to average the value, or sometimes you just create the average value of that certain week in that certain month and give it to it. So how do we do such a thing? Grouping or averaging based on another variable. For example, I want to, this one, it's female, so I want the average of other females. There's a problem here because I have only 70, so this will be another 70. But in a bigger data set, of course, if I have it here specified as a male, for example, then I will have 62 plus 25 over 2. So that will be the average whenever it's a male, or the average whenever it's a female. So how do we do this? As you can see here, I never had any problems or any messages. Maybe I have some problems with the internet. But this is not supposed to be the case, has nothing to do with that. Did I have a little mistyping? Oh no, same situation. Okay, in any case, let's keep going. So how do we here group based on the sex? So fill NA, and first of all a group by sex, and then just without anything in between, just put pretest score dot transform mean. So this is how we do it, and with this we will get over here. I think it should be not a pretest, it should be a post test. Sorry, so here a post test because we're working with post test. So over here will be post test. It's not even working, guys. I'm sorry. I think something has happened. Let me just refresh, because it's not giving me the right here. I think even here I'm trying to correct the post test. So as you can see here, I have 70. Why? Because female only 70, so it's going to be the same number. But if it would have been more interesting if it was male, then I would have got 25 plus 62 over 2. All right, so it should work. I don't know why I'm running into some problems now, but what's wrong? This should work, guys. I'm so sorry. So I'm running into problems right now, but as you can see, last night I just worked with this data, with this file, and everything just went fine. It's not really, it's sometimes it's just stuck. I don't know what's wrong with my file. You see, it's not giving me any here. It's not returning the data frame even. I think I'm gonna just close this for now and restart again. And I'm gonna do it manually. Okay, here's the data frame. Okay, a little problem, all right. But we got the output anyway. No, we didn't. Guys, I really don't know what happened to this file, that it's got corrupted all of a sudden. Because as you can see here, I'm just the same exact code, you know, we're using here the same exact code, and it should just work just fine. I've been using this here forever, so now it's working fine. Let's see this one, which is supposed to be 70. Still not working as intended. It's not reading the postdoc well. But it should work, guys. I mean, I hope with you it should work. Oh, wait a minute. No, it should just work fine even if I don't have. Let me check. Do I have? Yeah, I have it. This is quite interesting. Guys, I'm sorry. I think you should be able to get the correct results. Yeah. Over here, I keep on executing the same lines and I'm getting the correct results. It's just sometimes it happens that maybe I need to close the whole thing and reopen again, but this will take me a while. So things might happen, things like that might happen. So please be patient. So over here, as you can see, it's just working fine. All right. In any case, this is how we deal with correcting the data set. I maybe have to stop here just to restart everything, because the next step was to just now kind of let me just see if things gonna work fine. Here I created dummies. Now for categorical data, I'm gonna show you again. how to deal with it. For example, we want to create dummies over here, so I'm going to create dummies, and usually male is kept because it is signaling 1, and then female is 0. So basically we're going to do like we're going to do here a merge of the data frame and the dummies that we have over here, and we've done this in class, I think. Did we do the dummies? I did it in the previous video, yeah. So now we have the female and male. Now we want to drop sex, and we want to drop F, which is female. So we're just gonna do the merged dot drop. Merged is the name of the data set now, and now I gave it a new name, which is data set. So now this is the data set cleaned, but I want to rename M with sex again, so it shows that it is 1 or 0, and here it is. Now we have a clean data set with nice variables, all clean. There are always values over here. I don't like the value here being 3. In fact, even here is also 3. I'm gonna look into this, and this is 70 df 70. Yeah, now it's all right. So you should get a data set as clean as this one. As you can see here, I don't have any problems. I think little thing that maybe I've done earlier over here, df is a drop all, df with a threshold. I see. Because of this line, I believe, because of this line, the df with a threshold 5. Now I don't have any NAs, so it caused a little bit of a problem here. You see? Now I don't have any problems. Okay. Let's see. I don't. Is that true? I don't have the error. But I don't have the correct answer here. And this is quite annoying. And this is why I always tell you guys, I love and I like to always call the not overwrite on the data frame. This is why I always tell you, I made a mistake right now. I told you, okay, for now, just for a quick done, let's just rewrite on the data frame. You see what happens when you rewrite on the data frame? Problems happen. And this is why I always say, you just have data frame 0, data frame 1, data frame 2, and I think I've mentioned that in the previous video. And this is something that we need to look after. So this is here. I'm gonna save this. I'm gonna close it, and I am on a mission now to fix it. So this is here. So we read this is the missing values. This is the shape, whatever it is. This is the descriptive analysis. Yeah. So we already created the dummies. In fact, they are already available. We could have used them. Oh no, we could have not. Yeah. Okay, so here's the percentages nicely, and here's visually. All right, now this is the data frame so far. So what I did is I cleaned the data frame here. I don't want to do this, so I'm gonna just skip this part, and let's check what the data set looks like. It looks like this. Now this is pretest to pretest. Give me the mean. All right, I don't want to start with this. I want to start with this and see how it's gonna work. I have a problem here. and this won't work still. Hmm. Mm-hmm. Mm. Mm. Uh, uh, okay. I see. Okay, I don't think you will get the same problem as I did, guys, and I don't have the same problem with the other with this file. I don't have the same problem, as you can see. But when I have this second file that I'm doing the same thing with the same folder, then I have similar problems, and I understand now why. But you shouldn't have the same problems. You should have something similar to this, something so clean, so nice, similar to this. I'm having problems, guys, because I've already worked on this in a file saved in the same folder, but you won't have any problems. You will have this cleaned up this way, and this should be your result. So please don't worry about it. Okay. Anything else, please contact me if there's anything you don't understand, or if you run into problems. I'll help you troubleshoot. Thank you so much, and I'll see you in class.